The exponential function of the graph shown below. So I'm looking at points in the graph. It looks like it crosses at 0 on the x, 2 on the y, and then like at 1 on the x, 16 on the y. All right, that's enough information to find the equation of A. Here we go, A times B to the x in Newton. Okay, different letters can be used here. That's enough to find the equation of the graph here, because if you plug in 2 in for y and 0 in for x, or if you plug in 16 in for y and then 1 in for x. Now, actually, this one solves nicely. B to the 0 is just 1, so A equals 2 is what this equation tells us. And then if we plug in A equals 2 over into this equation, then it's clear that B equals 8. Okay? So now we have everything we need for the equation. A is 2, B is 8. You don't really, I think you have to put that parentheses in. Newton will be okay with it. 2 times 8 to the x power. So it's really about finding those points and then using the general form of the equation of an exponential function. That's a nerdy sentence, huh? Let's see, which of these graphs shows. So these are nice and easy ones, right? Because you can just try plugging in some values. Like if I just look at that function, if I plug in 0 in for x, I get 1 out for a y value. If I plug in, negative 1 in for x, negative 1 makes a positive 1. I should get out 7 for a y value. So negative 1, 7, that's not happening on this graph. Negative 1, 7, that's not happening on this graph. Negative 1, 7, that's not happening. Negative 1, 7, that's probably my guy. Negative 1, let's check the other point. 0, 1, that's happening. Oop, but that's not the right graph. Where are we? 0, 2, uh-oh, so that might not be it. Let's keep looking. Negative 1, 7, 0, 1, that looks like our guy. Yep, and that's got to be it, because it's got to match both points, not just one of them. Okay, I think there's another type of problem here. Let me see what I can do. Identify, yes, the same type of thing as the one we did before. Like 0, negative 7 would be a point I'd pick. 1, negative 14, plug that in, then you can solve to find out the exponential function. Yours might not exactly match what they have there because there's other ways of writing it that's still equivalent. But. So they ask you to graph this function 4 to the x plus 3 by moving the key points. So it's shifted up 3 units. That means my horizontal asymptote should be right here. Okay. The reason why I did that is because think of this term right here. 4, you can't raise it to a power to make it anything less than 0, right? You can't make this term be you could make this term get infinitely close to 0, but you can't make it equal negative 1. 4 to the x can't equal negative 1. 4 to the x can't equal negative 2. Okay, the lowest this could be is 0. 0 plus 3 makes 3. So 3 is the lowest y value we can have. So that's why I shifted it up. And then let's just try out plugging in some points. If you plug in 0 in for x, 4 to the 0 is 1. 1 plus 3 makes 4. Okay? So 0, 4, we got that matched up right there. Let's try another point. If you plug in 1 in for x, 4 to the first is 4. 4 plus 3 makes 7. So we got to make our next dot go 1 on the x, 7 on the y. That should be enough for Newton. If it isn't, then Newton's asking for too much, and this relationship just isn't working out. Same type of thing. Oh, well, let me do these. Okay, I can do this for you real quick, though. This term can be infinitely close to 0, so that's why there's no horizontal asymptote. But if I plug in, let's say if I plug in negative 2, negative 2 plus 3 makes 1. So at negative 2, I should be getting 1 on the y for the y value. If I plug in negative 3, negative 3 on the x, negative 3 plus 3 makes 0. 4 to the 0 should be sorry, this should be 4. Let me write it out because I'm confusing you, aren't I? If I plug in negative 2, then 4 to the negative 2 plus 3 should be 4 to the first, which is 4, right? If I plug in negative 3 for x, then negative 3 plus 3 makes 0, and 4 to the 0 makes 1. So let's just make sure those 2 points line up. Negative 3 on the x and 1 on the y. Negative 2 on the x and 4 on the y. There's our graph. I think there's another type problem. I'm trying to find it here. About vertical compression. I don't see it yet. No, we've done that one. Oh, come on. Done that one. No, we've done that one. Give me something new, Newton. No! Give me something new. No! Oh, I gotta do it. -2 is as low as we can go. If you plug in 0 for x, 4 to the 0 is 1. That gives us -1. So that works out. And if you plug in 1, 4 to the first is 1. 4 to the first is 4. 4 minus 2 makes 2. So I think that should be up there. I did that really fast. Hopefully I got it. Come on, there's one other type of problem. Okay, 2. Plug in 0, you should get out 3. Plug in 1, you should get out 6. Okay, now it has no choice. It's the last object. There it is. That's the one I wanted to do with you. Okay, so vertically compressed. So that means if you're thinking about it up and looking straight down, compressing a graph vertically, like if you start with a graph like this, and compressing it vertically, think about like some sort of I don't know, think about taking a book on top of this graph and pushing it down. Compressing it vertically means it's getting wider. Okay? So if you bring that back to quadratics, like if this is y equals x squared, then this would be like something like y equals 1/2 x squared. Okay? So vertically compressed means like you're coming straight up and down, flattening it with the book, it's spreading the graph out. So it's horizontally widening the graph. And we do that with a fraction as a coefficient, okay? And the reason why that is try testing some values in these functions. And you'll see it takes longer on the x-axis to get higher on the y-axis with this graph. Okay, so it's vertically compressed by a factor of 6. That just means 1/6. Now it's reflected across the y-axis, okay? So you could play around with like Desmos.com to see like what causes reflections in graphs. But if you do y equals x to the third, the graph looks like this. And if you do y equals -x to the third, the graph's going to look like this. It's a mirror image on the y-axis, okay? So if you change the sign of the variable from positive to negative, it reflects it on the y-axis. It flips it on the y-axis. So for my problem, if you plug in -x here, it's a negative times a negative. Might as well just call that a positive, okay? So that causes a reflection across the y-axis. If it is a reflection across the x-axis, you just multiply by a negative coefficient, okay? And then shifted up 1 unit, so we're going to say +1 here to shift it up 1 units, okay? Nothing confusing with a vertical shift. It's just plus or minus. Did I miss anything? Shift up 1. Yep. E to the 5x plus 1.